Okay, hello again. In this part, the fourth part of the tutorial, we will go through some research problems that either we are working from the CompMusic perspective, so that are applied to all the music traditions, and also the ones that are specific to Jingju music. So I will present the general introduction on the research problems that we're working on music, and then Rafael, Caro, Repeto will talk about Jingju music. So this is first my part, and then Rafael's part. So let's put back this slide that I showed at the beginning, in which expresses a little bit the research problems that we are working on and the methodologies we are using. So we are starting from data. We are starting from audio data and metadata associated with those recordings or to the music traditions that we are studying. And then we are using three types of engineering methodologies. One is signal processing, another one is machine learning, and the other is semantic analysis. So these are the main areas that we are focusing on. And the specific problems that we are working on are these ones. One is understanding melody and understanding the patterns that we can find in a melody. The other is about rhythm and understanding the rhythmic patterns. And this is the part that will be later on talked by Ajay and Sankal. And then there is this part of semantic relationships, and this is a part that we're not going to talk much here. This is kind of the newest one, and that relates with semantic technologies, and it's basically focused on text-based analysis and analyzing relationships that we can obtain from that. So we will be basically focusing on audio-related tasks. And then, of course, we are putting all that together into a prototype, the Dunya, that by itself also has quite a few research issues that we can study, especially related with navigation, exploration, the concept of similarity, how to display different aspects of the things that we have been analyzing. So again, melodic and rhythmic description are our main focus. The sources of data that we use for this type of analysis are either the symbolic data or the audio and the features that we extract from the audio. Not every tradition has a good symbolic representation that we can start from. For example, in the case of Turkish Makam music, and this is a fragment of a score from Turkish Makam music, we have a pretty good collection of symbolic scores, and that's a very good starting point for a lot of melodic analysis in Turkish music. But in general, the type of starting point we have are the pitch contours, the extracted pitch analysis that we perform on the recordings we start from. At the rhythmic level, there is some symbolic representation that we can start from, and again, this comes from the Turkish Makam tradition, but normally this is not something that we start from in terms of analysis, but these are good representations and good ways to then inform the analysis that we are doing on the audio data. And then on the audio data, again, we start with some sort of audio analysis that can identify like the onsets, and then from then on structure the rhythmic relationships. So one core part of our work is in extracting features that are useful for the particular problems we work on. And this is, for example, a fragment of a file of the descriptors having been extracted by Essentia, which is this library that I mentioned and that we are using for extracting these low-level features, and we're building on top of that and we are developing ways to extract higher level descriptions of that. And this can be visualized. This is a visualization using Sonic Visualizer, but this type of data can be visualized in different ways, and this is a good starting point for our work. So one of the first problems that we identified that were meaningful for some of our music traditions, and that I believe we did quite a bit of progress solving it, is the idea of tonic identification. From a Western perspective, tonic has a very particular meaning, but in every music tradition it deviates and it has a quite different meaning. So for example, this is the case of Indian music, in which the tonic is basically the drone that is played by a tambura or an electronic shruti instrument that generates this tonic. And it's a tonic and it generates a complex signal, but that has this tonic. And that's a very fundamental note, or very fundamental sort of concept from a melodic point of view that we need to understand in order then to do some melodic analysis. So a very important task has been to identify that automatically. So from a recording, to be able to identify which of the pitches is the actual tonic. And this is, for example, a visualization of the different pitch contours that can be found in a recording of Indian classical music, and different notes that can appear in that. Okay, and the idea is which one of these is the tonic, and then it can be done from a pitch histogram point of view, and by doing some analysis of these pitch histograms, and we have been doing some training on that, and we have been approaching this issue from different perspectives, and I believe we got pretty good results. So now, from an actual recording of Indian music, we can identify which one is the actual tonic of the piece. Another type of problem related to melody is the issue of intonation. And again, intonation, depending on the tradition, it might mean something different. We are not talking about tuning, so we are not talking about the tuning of a particular instrument. We are talking about basically the voice, the singing voice, and how it modulates the pitch in order to express a particular melodic concept, or in this case, and this is again from Indian music, the concept of a raga. And in Indian music, there is the concept of notes, the concept of swaras, but the idea is that every note, every swara, doesn't have a very clear pitch in the concept of a frequency, but it might be expressed by a region of frequencies. And what is fundamental for a swara is the time evolution, or the behavior of that pitch in time. So for example, these are in 4 different ragas, the same swara and the pitch histogram of that particular note. And we see that it's quite different. So the same note sung in different contexts, in different ragas, it can be sort of rendered in quite distinct way, and the pitch histogram captures some of these differences. Here we have basically the average. The histogram is the average of all the swaras of a particular piece, so we are missing the time evolution, which is also important. But with these, we can start getting an idea of the complexity of what does it mean intonation in a particular music tradition, like the Indian music tradition. And for example, this is the pitch histogram of a complete song. So we see the different notes or swaras and how they are not really very clearly kind of just a single delta function, which would be the ideal case, and that every swara can have a very different distribution, pitch distribution that can characterize that particular swara. So anyway, so that has been another area of work that is very interesting, and of course can be applied also to Xingqiang music. And then continuing with the concept of melody analysis, I mentioned scores are a very important part in some music traditions. For example, in Jingju music, that's the case too. So in order to be able to combine the analysis of scores with the analysis of audio, a very useful kind of tool or very important research to be done is the idea of aligning the score with the audio so that we can compare the same melody both from a symbolic representation and from audio representation. And many of these traditions, like the Turkish music, is not like in Western classical music that basically you render the score from beginning to end and you try to keep quite strict the thing that you see in the score. In Turkish music, there is quite a bit of freedom by the performer in terms of improvising, deviating from the score. The score is kind of a reference on top of which then the expressivity and the creativity of the performer plays a very important role. So there are, in most songs, you have sections that might be repeated or might be organized in a different way. So the idea of identifying a particular region and a particular, let's say, phrase, and then identifying where it is in the audio, that's a quite interesting thing to do. So it's not a sequential type of analysis. And from that, well, we have been working on a number of strategies to be able to do this alignment. In generally, the idea is to start from the score, from the symbolic data, generate a pitch representation from that. From the audio, do the same thing by doing pitch analysis and obtain the prominent pitch of that. And then trying to align these two. And the idea is to use as much information that we can get in order to do a good alignment. So for example, the tonic identification that I mentioned can be very useful because the tonic of the audio may not be the same than the score. So it's good to be able to normalize the two so the alignment is done correctly. And of course, tempo might also be a very good thing because the nominal tempo that the score might have might be quite different from the audio. Therefore, if we can identify the tempo from the audio, we will have a better chance to do a good alignment. Anyway, and this is the work by Serra and in his PhD, and he has been doing some work on different ways of doing that, and whether you do the tonic or not, and the type of scores that you do. You get worse score if you don't use this tonic information, and if you do it, you can get a pretty good matching. And this is kind of the lines that identify this alignment between the score and the audio. Okay, and this is for the tempo and how the tempo can be used. And then this idea of finding sections is also an important thing. No? So a piece of a score may not be present all throughout, and you just have to find where these sections are. And out of that, then you can do this idea of sequential linking. A rendering of a piece of music will have a sequence of sections that might be repeated in different ways, and we want to know what is the sequence of these sections and how they are sort of structured in time and organized like that. Finally, an important thing that we need to do, especially in some research problems, is align at the node level. And that's quite a bit harder because in some of these traditions, like in the Turkish one, there is a lot of freedom at the node level. So there may be a lot of difference between how the durations or the exact pitches of the score and what it is in the audio recording. But that's quite an interesting challenge to work on, and that's what we're doing. And then another related problem is the lyrics to audio alignment. A lot of these traditions, and the Xingqiang music is a particular case, that's a very important problem. We have the lyrics of the aria, and it's very useful to have them aligned so that then you can do studies of the lyrics and the music and the instrumentation all together. So the alignment of the lyrics within the score to the audio, it can be approached in a similar way to the score to audio alignment, but it requires some speech models or some singing and phonetic models, and that's what we have been working on. So we have been applying some speech recognition and using HMMs to have a model of the particular language, particular singing, and then use that to align it with the audio and identify those phonemes or those singing phonetic units and be able to align them like that. And in the case of Turkish music, we are getting pretty good results. So this is some of the model that we are trying, the phonetic modeling that we are doing in the case of Turkish music, and how we extract the features and how we develop the HMM models. And this is a table that captures a little bit of the results that we are getting for the case of male, female. And these, is pretty much at the level of the state of the art with English and other type of music. So we are in the right direction of being able to do this alignment. Okay, and finally, before going into the Xingju music, I just want to mention the idea of music exploration, that we are not going to spend much time of it. We have this Dunia website, and within that, there is quite a lot of problems that emerge when we have this corpus. We have all these information, metadata, we have all these descriptions about the artists, about the recordings, and we want to make sense out of that. And here there is also quite a bit of interesting research at the semantic level, at the audio and collaboration with the semantic analysis. And that's what we're doing, but we are not going to talk much about that. We just leave it like this, but of course you can look at this website at Dunia, and in fact quite easily you can see how many interesting things can emerge by studying and developing technologies for this type of thing. Okay, and that's it. So now let's go to Rafael, that he will give us some sort of description about the kind of topics that are more specific to Xingju music. So let's stop here.
Okay, once we have seen how Jingju music works, we have the more important concepts in Jingju music, and we have presented what is the framework for our research, what are the tools we are using for our work, and what kind of task we are interested in our research. Now I'm going to identify what are the relevant tasks for working with Jingju music. Here are the most general tasks. First, we have 3 tasks, which are the core of our research, because related with the core concept of Jingju music, as we saw in the presentation earlier. That is the analysis of Shengqiang, of Banshi, and roll time. But we also are interested in other tasks that are not less important than those, but are not related to the core concepts of the music, which is the instrumental sections, as we're going to see in a minute, and then some analysis of the performance of the music. We have to notice that none of these topics can be researched isolated from the others, regardless of the others, because they are all connected into this one production of music. So let's see in detail some of these tasks. Before going into that, I want to mention that I have used these signs. So the logo of CompMusic in color and a little bit bigger means that we are working in this task. And when the logo is smaller and gray, it means that we intend to work with that, but we are not doing it yet. So for the analysis of Shengqiang, as we said before, we're always working with arias. So arias is our research object, but for the case of Shengqiang, we're interested in the singing line, in the vocal part of the aria, because as we saw, the vocal part is the most important melodic part of the music, and the instrumental accompaniment is basically the same melody with some specific ornamentation interpretation in this heterophonic texture. So in order to work with the singing line, we need to do these previous steps. First, segmenting the aria into singing parts and non-singing parts, including here like percussion parts, instrumental parts, or sometimes recitatives that are inserted in the area. So we need to extract where the singing part occurs to analyze only that. And then we have to extract the predominant melody for this vocal part, for this singing line. We'll see how we're doing this now. We're working already with that. Sankalp will talk about that in detail later on. Once we have done these previous steps, then the analysis consists first in computing histograms for the pitch of the melodic line. These histograms will be aligned to the first degree of the scale. So we have the horizontal axis in cents with 0 in the first degrees. With that, we can see the distribution of the degrees of the scale for each Shengqiang, and also the register and the range for each of them. Sankalp will also talk how we're working with this. And we also intend to work with some melodic similarity. As we said in the presentation earlier, Shengqiang is originally one melodic line, one melodic skeleton. So we suppose that some melodic similarities has to be there in order to identify the identity of the Shengqiang. We also want to work with intervallic distribution, so to see what are the intervallic trends for each of the Shengqiang, and also to plot some schemata for the cadential notes, as we saw, which is currently in the literature the most important explanation of the Shengqiang. So in order to do that, we can also benefit from some other related tasks. For example, the lyrics to audio alignment, especially in the poetic sections level. That means the line, the couplet, the line, and the subsections of the line. Because as we saw, the lyrics are crucial for this music because it's theatrical music and it's everything about telling the story. So the music is also related to the structure of the lyrics. So once we have this aligned, we can also work with the structure of the music. And also if we have the score aligned to the audio, we can also benefit from that for the computation of the first degree of the scale. So we can have the histogram aligned to or normalized to the first degree. And we can also work better for the intervallic distribution and the computation of the cadential notes, because as you listened before, this music have a lot of glides and vibrato, so it's better for working with notes to have the score aligned to the audio. So that's about the analysis of Shengqiang. For the analysis of Banshi, which is the metrical patterns, we're also working always with arias, as we saw before, but now we're interested in the temporal features, in the rhythmic features of the aria. So for that, we need also to start segmenting it, starting out the percussion parts, because there's no tempo or meter there to work with. And this is also useful for some other tasks we're going to see in a minute. And we will be working with the melodic parts, including both instrumental and singing parts, because that's where the tempo is marked. Then we have to detect the onset for instruments, and we're already working with that, and Ajay will explain about this. But also about the onsets of the voice, of each syllable of the singing, because this is the most important part of the rhythm. And when a human listener is listening to this music, he's always listening to the lyrics above all. And then we also need to identify the instruments, especially the pan, the instrument I played earlier, and the drum, because the instrument, as I said, that is marking the tempo. So once we've done these steps, the analysis consists in the computation of tempo and identification of meter. As we saw, Banshi is defined mostly by a tempo range and a meter. So in order to identify those and analyze how they work, we need to compute the tempo and meter. There's some difficulties and challenges working with that, as we listened to the sample before. There's a lot of flexibility in the tempo and in the performance of the rhythm. So we have to handle that. We haven't started yet to work with that, but it's in our schedule. We also can benefit from the lyrics to audio alignment, in the sense that if we have the lyrics aligned to the audio, we can very easily or more easily compute the onsets of the syllables. And then from the score to audio alignment, because with that we also have the measures, and we have the very easily identify the notes of each line. With that we can compute better the onsets and for the instrumental part. So that's about the analysis of Banshi. For the analysis of role type, the first steps are very similar. to the one of Shengqiang. We're also interested in the singing line. Then we have to segment the aria into singing and non-singing parts. And we have to start the predominant melody, as we see before for the Shengqiang. Then one of the elements for the analysis is the computation of pitch histograms, and with that we can compare the range and the register for each different role type, because they use different range and registers. But we're also interested in the analysis of timbre, vibrato, and dynamics for each of the role types. And it's very interesting to do it in the general framework, how they use timbre, vibrato, and dynamics in the general performance of the aria, but also for each syllable. As I said before, the delivery of the lyric is very important. It's crucial for this genre, and the actors pay a lot of attention of the delivery of single syllables. They take care of pronunciation and delivery of single syllables, so analyzing these syllables in terms of these features would be very relevant for identifying each of the role types. So these three tags were the core research tags, because they are related to the core elements of Jingju music, but we are also interested in some other research tags. For example, those related to instrumental sections. As we saw in the presentation earlier, the percussion patterns are very important in this music, so it's very important to have them identified and analyze how they are used in relationship with the other concepts. So identifying them, analyzing them is one of the tasks we're working already with, and Ajay will be explaining in detail how we're dealing with these tags. It will be also very interesting for this music to work to analyze the instrumental sections, the introductions, because they are related to the Banshi, and they will be very, very useful for identifying Banshi, and also to see the development of the interpretation. And also to work with the relationship between the accompaniment and the vocal line to analyze how these heterophonic textures works in Jingju, but we are not intending to work in that. We hope that someone can help us in implementing this kind of tags. Also, this genre, this kind of music is very interesting to analyze performance. We're going with the analysis of the tonal categories of the language and how they influence the melody. As we saw before, Chinese is a tonal language, and the tonal categories of the lyrics has to be expressed somehow in the melody, and we're trying to analyze how this happened. But there's also a very interesting genre to work with the performance of schools, how different schools of performance are delivered, and how they differ one from each other. And also it's very interesting genre to work with the relationship between the acting, the visual part, and the musical part. And with that, we need to work with some researchers in video. We're not doing that, but it is a very good example, very good music to work with this relationship with the visual part and the audio part. And finally, Jingju music poses some interesting challenges for the concept of browsing and exploring the music, because in Dunia, as Xavier played, showed earlier, Jingju music have some specific concepts that have to be displayed, and they have to be used for the browsing of the corpus. So it poses some challenges and interesting topics for research in this field. So that was about this fourth part. We've seen what are the research we're doing in the framework of the CompMusic project, what kind of tasks we're addressing, and which of these tasks are interesting for research in Jingju music. Now, Ajay and Sankar will present in detail some of these tasks, especially melodic and rhythmic analysis. And with that, you can see the tools we're using and how they're implementing for these tasks. Thank you.